Just imagine this for a moment. You are gazing at the vast expanse of space, where stars flicker like distant fires in the cold, and your eyes fix upon Saturn, the majestic ring giant of our solar system, and just beyond its magnificent rings lies Titan, a moon shrouded in thick orange clouds, mysterious, distant, and mostly hidden from our direct sight for decades, a place that has always seemed like a frozen desert, with rivers of liquid methane, lakes of hydrocarbons, and a frigid surface that seems utterly inhospitable to life as we know it. Yet beneath that icy, alien exterior, NASA has just uncovered something so astonishing, so mind-bending, that it challenges everything we thought we knew about moons, planets, and the possibilities of life beyond Earth. Because hidden beneath Titan's frozen crust, beneath the clouds and methane lakes, there exists a vast ocean. Possibly larger than all of Earth's oceans combined, an ocean of water and perhaps other chemicals, locked away under layers of ice that could be tens or even hundreds of kilometers thick, completely isolated from the sunlight, yet surprisingly dynamic, moving and shifting silently in the eternal darkness of this alien world. And as NASA's Cassini spacecraft and radar instruments mapped the surface over years, hints of this ocean began to emerge, not through direct observation, because nothing can penetrate the thick ice directly, but through subtle gravitational anomalies, slight wobbling of Titan's orbit, magnetic field measurements, and thermal emissions that indicated liquid water might be hidden below. And when scientists combined all the data, the picture that emerged was both beautiful and terrifying, because it was not just a small subsurface ocean, but a global one, encasing the entire moon like a hidden heartbeat beneath the frozen shell. And the implications of this are staggering, because where there is water, there is the potential for life, and life, even in the most extreme conditions on Earth, finds a way, from hydrothermal vents at the bottom of oceans where sunlight never reaches, to acidic lakes, to frozen tundras. Life adapts, evolves, and survives. And so the possibility that Titan's ocean could host some form of alien life, even microbial, ignites the imagination and raises questions that have haunted humanity for centuries. Are we truly alone in the universe? Or have we simply been looking in the wrong places? Because Titan is far colder, far stranger, and chemically far more complex than any ocean on Earth, with a dense nitrogen atmosphere, methane clouds, ethane rain, and hydrocarbon rivers cutting through icy plains, creating a landscape unlike anything seen before. And yet beneath all this lies the tantalizing promise of water, movement, heat, and chemical interactions. And when NASA analyzed the latest readings from gravity measurements, it became apparent that the ocean is not just static, it is dynamic, possibly in contact with a rocky seafloor, where chemical reactions could provide energy sources that life could exploit. And the thought alone sends chills down the spine, because billions of years ago, Titan may have shared conditions similar to early Earth, with stable water, complex chemistry, and potential for prebiotic reactions. And now, hidden under kilometers of ice, it might still harbor the remnants of that primordial chemistry, frozen in time but still alive in some microscopic form. And when we imagine a probe descending through the thick orange atmosphere, penetrating the ice with drills or sonar, entering a dark, alien ocean, the suspense becomes almost unbearable, because humanity would finally glimpse a completely alien ecosystem, a world unlike anything on Earth, with currents, perhaps even gigantic icebergs drifting silently, nutrients moving in invisible flows, chemical reactions creating strange bubbles and eruptions from the seafloor, all under crushing pressure and in total darkness, yet alive, dynamic, mysterious, waiting for explorers to reach it. And the implications extend beyond mere curiosity, because discovering life, or even the conditions for life, on Titan would rewrite biology, chemistry, and our understanding of life's resilience, proving that even in the coldest, most extreme environments, life can emerge, adapt, and survive. And when NASA's scientists released this discovery, the world reacted with awe, fear, excitement, and questions, because suddenly Titan was no longer just a moon, no longer a distant orange dot in the sky. It became a symbol of cosmic mystery, a potential harbor of life, and a reminder that the universe is far stranger than our imaginations. And when we think about the challenges of reaching Titan, a voyage across billions of kilometers, entering an atmosphere we barely understand, landing on ice that could crack or shift, drilling through kilometers of frozen crust to reach the ocean below, deploying submersibles in a completely alien environment where sensors must survive crushing pressure, extreme cold, and chemical hazards, the endeavor seems almost impossible, yet utterly compelling, because the secrets held within that hidden ocean could answer questions humanity has asked for centuries. Where did we come from? How common is life in the universe? And could we find a second home among the stars? And as we visualize the instruments probing beneath the ice, detecting currents, mapping the seafloor, searching for chemical signatures, and even perhaps glimpsing life forms, simple or complex, that have evolved in isolation for billions of years, the suspense is electric, because every reading, every faint ripple, every chemical anomaly could signal something profound, something that would forever change our understanding of life, the universe, and our place in it. And when we consider the layers of ice, the methane rains, the swirling orange clouds, the alien rivers, and then the vast, hidden ocean beneath, we realize that Titan is not just a moon, but a window into the possibilities of life in extreme conditions, a laboratory untouched for eons, waiting for humanity to uncover its secrets. And so the discovery of a hidden ocean inside Titan is not just a scientific revelation, it is a cosmic invitation, a suspenseful, mysterious, and thrilling challenge to explore, understand, and perhaps even connect with life beyond our tiny, fragile world, a journey that promises discoveries far beyond imagination, that could redefine biology, chemistry, planetary science, and even philosophy. And as we await the next missions, the next probes, and the next brave explorers to venture toward Titan's frozen surface and its secret ocean, one thing becomes certain: the universe is stranger, more beautiful, and far more alive than we ever dared to dream. And as we prepare to imagine the next steps in exploring Titan's hidden ocean, the anticipation grows almost unbearable, because beneath that thick, frozen crust lies not only the potential for a life, but a dynamic world shaped by forces we are only beginning to understand, a place where tidal flexing caused by Saturn's immense gravity could create heat, currents, and geological activity strong enough to stir the ocean, mix nutrients, and generate energy sources for alien organisms. And as NASA's theoretical models combine with radar data and thermal mapping, the picture that emerges is astonishing, because the ice shell is not uniform. It is riddled with fractures, ridges, and chaotic terrain, suggesting that the ocean beneath is constantly moving, pushing against the ice above, creating pressure points that could form geysers or plumes. And when we consider that Cassini previously detected hints of such plumes, sending faint chemical signals into space that were captured by sensitive instruments, the mystery deepens. Because what might have been seen as methane or ethane venting could actually be evidence of complex organic compounds, possibly even biological in origin, and the suspense builds when scientists simulate how a probe or submersible could navigate such an environment, where darkness is absolute, pressure is crushing, and the ocean's composition is alien, unlike anything on Earth, filled with unknown salts, hydrocarbons, and perhaps chemical gradients that could support forms of life adapted to extremes of temperature, pressure, and chemistry. And when we visualize such a submersible descending through kilometers of ice, sensors humming, lights illuminating the inky darkness, the imagination races, because we might witness currents shaped by underwater mountains, icy chimneys venting chemical energy, and perhaps even bioluminescent organisms, flickering faintly in the darkness, evolved over billions of years without sunlight, thriving in a world completely independent from the familiar biology of Earth. And as we think about the implications of discovering even microbial life in such A setting, it is both thrilling and terrifying, because it would demonstrate that life can emerge and persist in environments far beyond our planet, that the universe is teeming with possibilities we have scarcely begun to imagine. And as NASA plans future missions, discussions around landers, ice-penetrating drills, autonomous submarines, and sonar mapping become heated. Because each decision could mean the difference between success and failure in capturing humanity's first glimpse into an alien ocean, and the suspense is amplified by the knowledge that Titan's extreme conditions will challenge every piece of technology ever sent into space.